Hello, give this problem a try. Apply Hopital's rule. Pause the video. I'll do the work on the board and you can compare what you have. Did I? Alright, so plug in the 0. I'm going to get e to the 0 minus parentheses 1 plus 0, 0 squared. E to the 0 gives me 1 minus 0 over 0, so I end up having an indeterminate form 0 over 0, which means I'm going to apply Hopital's rule, take the derivative of the numerator. Derivative of e to the h is e to the h. The derivative of h is going to be 1. There's a minus sign here, so it's minus 1. The derivative of h squared is 2h. Again, I plug in the 0. I'm going to get 1 minus 1 over 0, which again is an indeterminate form, 0 over 0. So again, I can apply Hopital's rule. The derivative of this is going to be e to the h over 2. Put in a 0, e to the 0 is 1, so the answer is 1/2. If you had difficulty with this, do it over. If it happened to have ended up that it was 0 over 0 again, I would keep applying Hopital's rule. All right, here's problem 46. Try that one, see what you end up getting for the limit. So pause the video and try the problem. All right, so if you plug in x equals infinity, you're going to get infinity over infinity, because any number to infinity is going to ultimately be infinity, which means you have an indeterminate form of infinity over infinity. You can apply Hopital's rule, take the derivative of the numerator, which is 2x, derivative of e to the x is e to the x, plug in x equals infinity, and again you get infinity over infinity, which is an indeterminate form. So you can again apply Hopital's rule. This time you're going to get 2 over e to the x. The limit as x goes to infinity is going to be 2 over e to the x, which is going to give you 0. Because this is a constant, this number is going to get extremely large, and the answer is going to approach 0. All right, I want to try problem 68. First thing you want to do is remove the radical signs and replace them with fractional exponents. So go ahead and do that. All right, so it should look like this. Now remember, the sine function, sine of theta for this problem is b over c. As theta goes to 0, the length of b goes to 0. All right, so these are going to equal 0 over 0. So take the derivative of the numerator and the derivative of the denominator. Apply Hopital's rule. Pause the... Okay. You can simplify that. Plug in 0. See if you get 0 over 0 again. All right, so pause the video, try it, and I'll simplify it. All right, if you plug in, you do this division here, you'll find out that you'll end up with 0 over 0. This is the derivative. This is the derivative simplified. So apply Hopital's rule again and see what you get. All right. Now I'm leaving out some steps and an explanation. I want you to try to figure out what's missing, what steps I've left out, why this is the correct answer. Okay. All right, try problem 70. You have to do some trig manipulation on it. Do some substitution. So pause the video, see what you can do in the way of trig substitution. And you might want to look at that closely. All right, cotangent of x over cosecant of x. Cotangent is equal to a over b, which means it's going to be equal to the cosine over the sine. Cosecant is 1 over the sine of x. do the division, the signs will cancel. So you get cosine limit as x goes to 0 from the positive side, cosine of x is going to equal 1. All right, page 116, number 20. Limit as x goes to negative infinity of the inverse of the cosecant of x. Well, this is equal to the inverse of sine 1 over x. If you put negative infinity in there, you're going to get 0, and the sine function is equal to 0 when the radians or degrees are 0. Okay, on page 116, number 22. Now you have the derivative formula for the arc's cosine on page 115. It's this here. I want you to take the derivative of this, which means I want you to plug it into that formula. So go ahead and give that a try. I'll put it on the board. Pause the video, see how you do with it. Okay. Now this can be simplified further by using some simple algebra. So go ahead and try to simplify it, see how you do with it. All right, so found a common denominator, which is x squared. And that becomes x squared minus 1 over x squared inside the square root sign. Square root of x squared is x. Take it out, simplify it. All right, take a look at problem 24. You want to use the formulas that's on page 115. Ask yourself, though, what is the domain and what is the range of the inverse sine function? So find the formula on page 115, plug it in, see how you do it. I'll put it up on the board. Pause the video. All right, using the formula that's on page 115, I get 1 over square root of 1 minus square of this value here, which is 1 minus t squared. And the derivative of this, 1 minus t, is negative 1. So it's going to be negative 1 in the numerator. Then I'm going to multiply out this. So I'm going to end up with negative 1 over square root of 2t minus t squared. Now remember, for the domain and range, this is a sine function. For a function to have a inverse, it has to be 1 to 1, which means that it's going to be from negative pi over 2 to pi over 2. I'm going to truncate it. So this is going to become the domain, negative 1 and 1, and the range is going to be negative 2 over pi over 2 to pi over 2. All right. Take a look at number 26. All right, look on page 115 for the formula for this one. Apply it, see how you do with it. Pause the video, give it a try. All right, this is the formula I want to use. So U is 5s. Tells me put the absolute value of 5s in front of the radical in the denominator. There's a 1, here's the 1. And then I'm going to square the 5s. So it's 5s squared, which is going to give me 25s. And I have to take the derivative of 5s, which is 5. So it's going to be 5 over 5, the absolute value of 5s, square root of 25s squared minus 1, which is going to give me 1 over the absolute value of s, square root of 25s squared minus 1. If you didn't get it right, try it over. All right, I'm going to leave 44 for the next time. Homework is your handout. I'll send you a handout by email. You have a quiz on my math lab. Page 106, numbers 43 through 46, 67 through 70. Page 116, numbers 19 through 26, and number 43. All right, now if you got an 80 or less on the test, there's a makeup test on my math lab for you. You have to take it within a week. If you email me, please use Blackboard's email so everybody, and reply to all, so everybody gets the question, unless it's a very personal question. Thank you. Have a great day.